All right, let's look at the homework 14.4, problem number 10. All right, so we have two curves, and I guess they intersect at the point 3, 1, 3, and we want to find the tangent plane to the surface that includes both of those curves. All right, so let's do that. All right, so look at curve 1. We're going to find the direction vector. So I'm going to just go ahead and take the derivative. So you have a R1 vector and a prime of t. All right, so this is going to be, all right, so you have a 3 here, comma, and it's going to be negative 2t, comma. All right, 3, 0, so you have a negative 5 plus 2t. All right. Then since the point is 3, 1, 3, and in this case, so 3 plus 3t has to be equal to 3, so t is equal to 0 at that point. So plug it in t equals 0, we can find, right, so we can find the direction vector. I'm going to call it direction v1, all right? So this is going to be r1 prime of t is 0 at that point, right? So you have 3 comma and 0 comma negative 5, right? So that's the direction vector of the first curve. All right, so let's do the same thing. We take the derivative of r2, right, with respect to u this time, right? So we get all right, derivative of u squared, derivative of 2 is 0. U squared is 2u, comma, 6u squared, comma, just 2. All right. So, to find v2, so direction vector for the second curve would be r2 prime of. All right, so this one you have to be a little bit careful. So u value is actually at this point, so t value was 0 there, but the u value is actually maybe 1. All right, so let's see, 2 times 1 cubed minus 1 gives you 1, and 2 times, so u is actually 1, so it's going to be equal to 1. So we have to actually plug in 1 there. Right, so we get 2 times 1 is 2, comma, 6 times 1 squared is 6, and then comma 2. Right, so we have that. All right, so once you have two direction vectors, and what we want to do is we want to find a vector perpendicular to that. All right, so the good way to do is take the cross product, so v1 cross v2. So you're going to get, right here is I, J, K. All right, v1, it's 3, 0, negative 5. And you have a 2, 6, and 2. Right? So this is going to be equal to, right? So we're going to have, it's a 0 minus negative 30. So it's going to be positive 30, comma, right, minus, and it's going to be 6. 3 times 2 is 6, minus 10. So it's going to be a minus negative 10. So it's going to be plus 10. Right? And the last one is 18. So we have 18 here. All right. So we're going to get the, so this is going to be 30, comma, negative 16, comma, 18. All right. So I'm going to just, since these are big numbers, at least they're all even. So we can pull out the 2 from there. All right, and you have 15, comma, negative 8. comma 9. All right. So what I'm going to do is I'm going to take only just this part. So this is going to be our normal vector of the tangent line. All right. So all we have to do is we know the equation, right? So it's going to be 15 x minus 3 minus 8 y minus 1 plus 9 z minus 3. And this is equal to 0. Right? So let's type it in. Right? So we got 15 x minus 3 minus 8 y minus 1 plus 9 z minus 3 equal to 0. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, and what I want to do next is since we're done with this problem, so I want to make sure that this looks right by using GeoGebra. Alright, so let's try to sketch those curves. So the curves are 3 plus 3t and comma and 1 minus t squared comma 3 minus 5t plus t squared. Right, then hit enter. Right, so you can see that we have a curve. Let's see, I'm gonna just let's see. Yep. Oh, all right, so this looks a little bit better. So you have a curve here, right? And the point is 3, 1, 3. So I'm going to put the point there too. All right, so you have a 3, 1, 3. So that's the point. All right, the other line, I'm going to use t for this too. 2 plus t squared, comma, and 2t cubed minus 1 plus 2t plus 1. Right? So you can see that there are two curves intersecting at this point 3, 1, 3. Right? Then what we want to do is we want to come up with the tangent line. So let's see. All right, tangent line we came up with is 15 x minus 3 minus 8 y minus 1 plus 9 z minus 3 equal to 0. All right, so let's see if it looks right. So you can see that here the plane that we came up with touches both curves at the point 3, 1, 3. All right, so it looks like we have the correct tangent plane. All right, that's it. I hope that this was clear.